Welcome back to my YouTube channel. Today we'll be using Elementary Mathematics June 2015 number 1. So please like, subscribe the video.
Okay, question 1. Question 1 says, given that f of x is equals to x minus 1 and x minus 2 with x equal to 2, then the range of f of x is. So yeah, in this question, they're asking us to calculate the range of f of x. So they've given us the different answers. So yeah, to calculate the range of a function, what do we need? We know that the range of the function is what? It is a domain of the inverse of that function. So we have to find the inverse of the function, and then we get the domain of the inverse of the function. So we'll start by finding the inverse of the function. To find the inverse of the function, we say let y be equal to f of x. Let y be equal to f of x. So now then that implies that y will be equal to what? X minus 1 and x minus 2. Then the next step, we make x the subject. If we make x the subject, we'll have x will be equal to 2y minus 1 and y minus 1. So then now x will become f inverse and y will become x. So we have now our f inverse of x. So here now we say that our f inverse of x can take all values of x except what? Except 1. Because when we put 1 in the function, it makes the function undefined. So the domain of f inverse of x is what? Is all values of x belonging to a set of real numbers except what? Excluding 1. So therefore our range is all values of x element in arrow excluding 1. So here if we compare, we see that the answer here is C. Yeah. Okay. Question 2. Question 2 says the function f and g are valid functions. Given that g of x equals to this and g composite f of x is equals to this, then f of x is, and I've given us the different answers. So here, they've given us g of x, and they've given us g composite f of x, and they're asking us to find for f of x. So what we do? We know g composite f of x is what? Is g of f of x. Means that in the place of x, I put what? F of x. So I go to my function of g of x. So I go to my function of g of x and replace. Anywhere I see x, I put what? F of x. But I already know up here that I'll be giving me that g composite f of x is equal to 7.3x minus 5. So now then I equate the two. Yeah. So if we equate the two, we have this. Then we cross multiply and we simplify and we make f of x the subject. And if we make f of x the subject, we have 3x plus 9 on 3x minus 12. So we can say that 3 can divide all through. So we divide by 3, we have our f of x equals x plus 3 on x minus 4. So if we compare it with the different answers, we can see that here the answer is C. Okay. 3. Question 3 says the values of x that satisfy the equation 3 to the power 2x minus 10 into 3 to the power x plus 1 plus 3 to the power 4 equals to 0 is. So here the asking us to find for the different solutions of x that when we put here we'll have for 0, and I've given us the different answers here. So what we can identify is that this is an indices question. So we'll start by simplifying it. So they've given us this. We know that 3 raised to the power 2x can still be written as what? Can still be written as 3 raised to the power x other squared, and 3 raised to the power x plus 1 can still be written as 3 times 3 raised to the power x. That's the loss of indices. When I'm multiplying two things that have the same base, we add the top. And we also say that 3 raised to the power 4 gives us 81. So now here we start 3 raised to the power x is common. We say let m to equal to 3 raised to the power x. Replacing it, we have m squared minus 30m plus 81 equals to 0. Looking for the factors, we look for two numbers, and when we multiply them, we have 81. And when we add those two numbers, we have negative 30. So we can say that those two numbers are negative 3 and negative 27. Because if we take negative 3 times negative 27, we are going to get 81. And if we take negative 3 plus negative 27, we are going to get 30. So those are the factors. So I'll just write in the form n minus 3 times n minus 27. Making n the subject, we have m to be equal to 3 or m is equal to 27. But we know that n is equal to 3 raised to the power x. So this implies 3 raised to the power x is equal to 3 or 3 raised to the power x is equal to 27. Putting in the index form, we have 3 raised to the power x is equal to 3 raised to the power 1, or 3 raised to the power x is equal to 3 raised to the power 3. So this implies that what? The bottoms are the same, means that the top will also be the same. So this implies that x is equal to 1 or x is equal to 3. So if we are comparing with the answers, we see here the answer is okay. Question 4. Question 4 says that the solution of the differential equation y divided by dx equals to 2x, given that y equals to 1 when x equals to 1 is. So here they're asking us for what? They're asking us for the solution of the differential equation. Means that they're asking us to come out with the equation of the form maybe y equals something, yeah. So the first thing that we'll do here when we see this equation is that we separate variables. We'll put the x and y on one side. We put the terms that have x on one side and put the terms that have y on the other side. So doing that, we are going to have y dy is equals to 2x dx. So now after that, we pass integration on both sides. So we have the integral of y dy is equals to 2 times the integral of x dx. I factor the 2 outside because 2 is a constant, it doesn't depend on x. So that's why I send it out. So then now integrate. If we integrate, we'll have y squared on 2 is equals to x squared on 2. Now that 2 will cancel with that 2 that was outside. With this 2 outside here, yeah, and we'll have just x squared now plus k. So now we need to find for the value of k. That we know that when x is 1, y is 1. So replace. So we're going to replace. On replace, we have that. So when x equals 1, y equals 1, we replace. Replacing and making k the subject, we have k to be equals to negative a half. Then now we replace k back in our equation. We have y squared on 2 is equals to x squared minus 2. We multiply now all through by 2. If we multiply all through by 2, we are going to have 2x squared is equals to y squared plus 1, which will be equation 5. Question 5 says in the set A equals to 1, 2, 3, 4, 5, and relation R is defined by R is such that x and y are elements in A and x is less than y. Then R is, they have given us different answers. Is R A, is it reflective, is it symmetric, is it transitive, or is it anti-symmetric? So we're going to go through all the answers and see which one is perfect. Let's start with A. So in this question, we are going to use the elimination method. So we're going to take the first case, that we're going to take A and check is it reflective. If not reflective, we're going to go to B, do the same, go to C on to reach the answer. So we start with A, reflective. For it to be reflective, it must reflect to the same element. That is, if we have x and x belonging to the element A, x must be less than x. But here we say that x can never be less than x. It is not true. So A is wrong. We'll go to the next, B. If it is symmetric, that means U relates V, implies that V will relate U. So U relates V, we'll have what? U relates V means that U and V are elements in A. That implies that U is less than V. And then V, if you want to show for V relates U, V relates to U will be what? Will be V less than U. But we cannot have U less than V and at the same time V is still less than U. It's impossible. So that's why B is wrong. We'll go to the next, C, transitive. It is transitive if what? We have U, if we have U relates V and V relates W, implies U relates W. So now let's start. What is U relates V? U relates V means that U is less than V, and V relates W means that V is less than W. Now, if we see here, we have here U is less than V, and here V is less than W. So when we join these two, we have this, that U is less than V and V is less than W. So here now, if U is less than V and it's also less than W, means that U is less than what? W. So we have this, and U is less than W implies that what? U is related to W, and that shows that it is what? It is transitive. So then the answer is C. But anyway, let's check Z. For Z, for it to be anti-symmetric, what does it mean? It means that if U relates V and V relates U, if and only if what? U is equals to V. So U relates V implies that U is less than V, and V relates U implies that V is less than U. But here they say it's less. It cannot be equal. So here this is wrong. So here our answer is what? C. Okay, question 6. The line segment PQ, where P is the point 7, 7 and Q is the point negative 1, 3, is the diameter of the circle. Then the equation of the circle is that we know the different answers. So if we have P to be x1, y1, and we have Q to be x2, y2, but which forms the diameter of the circle, then the equation of the circle will be given by x minus x1 times x minus x2 plus y minus y1 times y minus y2 to be equals to 0. So now replacing our P and Q, what do we have? We're going to have x minus 7 into x minus 1 plus y minus 7 into y minus 3. Simplifying gives us x minus 7 times x plus 1 plus y minus 7 times y minus 3. So comparing with the different answers, we see that the answer here is question 7. Question 7 says, when f of x is equal to this, if divided by 2x minus 1, the remainder is, so they're asking us for the remainder. So we have our f of x to be this. So we'll take the divisor, that's 2x minus 1. We equate it to 0 and make x the subject. So we'll have x to be equal to a half. So now if we put that half in f of x, it will give us the remainder when 2x minus 1 is divided by what? By f, when f of x is divided by, when 2x minus 1, yeah, when f of x is divided by 2x minus 1. So inserting the value of x in f of x, what do we have? We have f of a half to be equal to this. Simplifying, we have f of a half to be equal to 0. Comparing the answers, we have our answer to be question 8. Question 8 says that the range of the values of x for which the magnitude of x minus 4 is less than or equal to 2 is. So here now they want the range. They want to have to give us the range where it will satisfy this inequality. And I've given us the different answers here. So now we know the magnitude of x less than a implies what? It means that negative a is less than or equal to x less than or equal to a. So if now we have the magnitude of x minus 4 less than 2, what do we mean? It means that negative 2 is less than or equal to x minus 4 less than or equal to 2. Adding 4 on both sides, we'll have 2 is less than x less than 6. And when we compare with the different answers, we'll say our answer here is D. Yeah, okay. Question 9. Which of the following statement is true? So they've given us different statements here. Asking which one is true. We'll take the first case A. So A says that x squared is equal to y squared. If x squared is equal to y squared, that implies that x can either be equal to y or x can either be equal to minus y. But here they just say x is just equal to y, so it's wrong. It's supposed to give the two cases. Because if you take x is equal to negative 1 and replace, it satisfies the equation. But I've not put that case, so A is wrong. We'll go to B. B says if f of x equals to 0, this implies x is equal to AO. So this implies that x plus a is a factor. So yeah, if we have f of a to be equal to 0, so that means that x was what? Equal to a. To send a to the other side, we have x minus a to be equal to 0. So x minus a is a factor of f of x. But here in the answer, the two other is x plus a. So that's what makes B to be wrong. C says if f of x has maximum value at x equals to a, then f prime prime of a is greater than 0, which is wrong. If f of x has a maximum value at x equals to a, then f double prime prime of a needs to be less than. So for maximum, f double prime of a supposed to be less than. Why? If it's minimum, f double prime of a will be greater than. But if it is a point of inflation, it will be equal to 0. So yeah, we're also seeing that C is wrong. We'll go to D. D says that if we have two odd numbers, that if we add two odd numbers, we're going to have an even number. So now yeah, in maths, we know an odd number is represented as what? Maybe like 2k plus 1. That's an odd number. Where k is an element in the set of what? In the set of integers. So we say let m to be 2k plus 1, which is an odd number, and let n also to be 2t plus 1, which is also an odd number, for all k and t belonging to the set of what? Integers. So now we'll look for the sum. What will m plus n give us? If we add m plus n and simplify, we have 2 into k plus t plus 1. So now here we see that m plus n, it is a multiple of 2. And if something is a multiple of 2, then it is what? It is an even number. So here, since m plus n is a multiple of 2, then the sum of two odd numbers is an even number. So here our answer is D. Question 10. Question 10 says that given that f of x is equal to the magnitude of x squared, x cubed, 1, 2x, 3x squared, 0, 2, 6x, then they're asking us to find for f prime of x, and they've given us the various answers. So having our f of x to be this, and they're asking us for f prime of x, what are we going to do? We'll first start by finding the magnitude. To find the magnitude, you can use, so to find the magnitude here, I use this line. You can use any line. Most of the cases, we just use this line, but you can also use this line. So I use this line. So I hold x. When I hold x, I'll be left with what? 2x, 3x squared on 2x, 3x squared, 2, 6x. I do the same thing with 1. So the sign alternates. So it's plus, minus, plus. So the signs alternate. So I do the same thing with up to 0. And when I simplify, I have my f of x to be this 2x cubed. And then now when I differentiate it, I have 6x squared, which gives us B. Next, 11. 11 says that given that f is a periodic function of period 4 and f of x is such that you have x squared when it's in the range 0 to 2 and x plus 2 when it's in the range 2 to 4, then they're asking us for f of 9, and I've given us the different answers. So here now we can see that f of 9, x is 9, and in our range we don't have 9. What do we do? So we'll come back to understand what it means to be periodic. So if x is periodic of if it has a period of 4, what does it mean? It means that f of x plus 4k will be equal to what? F of x, where k is an element in the set of integers. So if I can write 9 in the form of something plus 4 times another thing, I can be able to express it. So yeah, we say f of 9 can be written as f of 1 plus 4 into 2. So we now, if we have maybe 1 plus 4 into 2, we just the same as f of 1. So f of 1, x equals to 1 lies in the first function, that's x squared. We place it there, so we have our f of 9 to be equals to 1, which gives us our answer to be A. Question 12. Question 12 says that we should find the volume generated when the area of the finite region enclosed by the x-axis and the curve y equals to x minus x squared is rotated completely about the x-axis. So that's what they're asking us here. And I've given us the different answers. So here we know the volume V is given by the pi integral from a to b of y squared dx. So now we have we know our limit. So it's from -1 to 1, and we place our y squared. So now we know that as our function is even, if you have an even function and you are integrating from -1 to 1, is it the same as 2 times you start from 0 to 1, or is it the same as 2 times you start from -1 to 0? So here it gives that an answer is question 13. Question 13 says two consecutive integers between which a root of the equation x cubed plus x minus 16 is equal to 10 is. So they have given us the different answers here, and they're asking us that for which values of for which two integers will this function has a value. So if f of x has roots between a and b, where a is less than x less than b, then f of a times f of b will be less than what? Will be less than 0. So we let f of x to be equal to x cubed plus x minus 16 minus 10. We'll send 10 to the other side. Simplifying it, we have our f of x to be equal to x cubed plus x minus 26. So now we're going to be testing the values. Like for a, we'll take what is f of 1. We'll take it and have the value. What's f of 2? And if we multiply it, is the answer less than 0? So let's do it. We simplify f of 1, we have negative 24. F of 2 is negative 16. Multiplying it gives us a positive number, which is greater than 0. So a is 1. B, multiply, we have negative 64, which is less than 0. So yeah, our correct answer is B. Let's check the rest. C, multiply, we have a positive number which is greater than 0. C, we have also a positive number which is greater than 0. So yeah, our correct answer is question 14. Question 14 says the vector a and b are such that a, the magnitude of a is this and the magnitude of b is that, and a dot b is equal to this, then a minus b is equal to, as you know, the different answers. So if we square both sides, if we square it, we have that a minus b other squared will be equal to the magnitude of a squared minus 2 times the dot product between a and b plus the magnitude of b squared. Then we replacing it, we have the magnitude of a minus b other squared is equal to 62. Then we take the square root on both sides. We have the magnitude of a minus b is equal to the square root of 62, which gives us b. Okay, go to the next. Okay, question 15. Question 15 says the sum of the first n terms, that's an error I put in. The first n terms of the series is given by s of n equals to 5 with 5n squared plus 2n. Then the nth term of the series is, and I've given us the different answers. So here we now to get the nth term. To get the nth term of the series, that's Tn, is equals to Sn minus 1. So then we replace, we have our Sn to be 5n squared plus 2n, and our Sn minus 1. And then in the place of n, we put what? N minus 1. We put now and we simplify. Simplifying, we have 10n minus 3. So the answer is question 16. Question 16 says the expansion of 2 plus 3x all to the power negative 1 is valid for, and they've given us different answers. So now, if we have the expansion a plus bx all to the power n, so this expansion will be valid when what? The magnitude of bx on a is less than what? 1. So now comparing with our own equation, with our own expansion, what we have, we're going to have that 3x, the magnitude of 3x on 2 is less than 1. So now we make x the subject. Making x the subject, we have what? We have negative 2 is on 3 is less than x, which is less than 2 on 3. Compare with the answers, it gives us, compare with the different answers, we have A. Next, question 17. The Cartesian equation of the curve with parametric equation x equals to 1 plus t squared and y equals to 2t, where t is a parameter, is That gives us the different answers. So we have x to be this, we call it equation 1. We also have y to be this, we call it equation 2. So from equation 2 to make t the surgery, we have t to be equals to y on 2. We call it equation 3. Then we take equation 3 and we put it into equation 1. If we place it in equation 1, we're going to have x equals 1 plus y on 2 other squared. Simplifying, we are going to have y squared is equals to 4 into x minus 1. And compare with the different answers of question 18. Question 18 says that we should find the limit as x tends to pi of 2 sine x on sine x. Yeah, if we see that we just put pi in the function, we are going to have what? Sine 2 pi, which is 0, all over sine pi, that's sine 180, which is also 0. 0 on 0 is undefined. So here we are going to use trigonometric tricks. So here we are going to see that sine 2x can still be expressed as what? 2 sine x plus x. So then now on sine x, so sine x and sine x cancels. I'm just left with the limit as what? As x tends to pi of 2 cos x. Then I put my pi. If I put my pi, cos pi, that's cos 180, gives us negative 1 times 2. We're going to have what? Negative 2. Comparing with the different answer, it gives us the of 19. Question 19 says that let's find the sum to infinity of this series. So, and I've given us the different answers. So here we can discover that we can identify that series is what? It is a geometric progression with first term a equals to 1 and common ratio r equals to half. And in our formula, that was we are being taught in school, that the sum to infinity is what? Is a on 1 minus r. So replacing it, we have 1 on 1 minus a half. Simplifying, we have our x infinity to the 2. We compare with the answers we have. 20. Question 20 says that the asymptote of the curve y equals this are. So okay, yeah, to get the asymptote, we have two types of asymptotes. That's what the horizontal asymptote and the vertical asymptote. So for the horizontal asymptote, is the limit as x tends to infinity of what? F of x. So we take our f of x, which is in this case is y. We look for the limit as x tends to what? Infinity. So we open the brackets and simplify. We have x squared minus 10x plus 25 on x squared plus 2x minus 15. So when you're finding the limit of a polynomial when x goes to infinity, you just take the highest degree. You forget about the rest. Just take the highest coefficient. Yeah. So yeah, in this case, we will just take x squared and we leave the rest. So we have x1 on x squared. Simplifying, we have 1 as the horizontal asymptote. For the vertical asymptote, these are the values of x which makes the function undefined. So just by identifying, you can see that if we put 5, if we put 3 and negative 5 in the function, we are not going to have values. So the domain of the function is what? The vertical asymptote is what? X is equals to negative 5 and x equals to 3. So therefore our vertical asymptote is that. So our asymptotes are x equals to 3, x equals to negative 5, and y equals to 1. So our answer here is C. Okay, question 21. Question 21 says that the values of y corresponding to the values of x are given in the table below. So that's the table. Then they say using the trapezium, the trapezium rule, the approximate value of the integral of y dx is, and as well as the different answers. So here we know the trapezium rule says that the integral from a to b of y dx is equal to h on 2 into y first plus y last plus 2 times y rest. So then now we replace. Here our h is the difference in x. If you want to see, x is increasing by 3. So our h here is 3. So we replace and we simplify. We are going to have the integrals equal to 28.8, which gives us d. Question 22 says that the gradient of the implicit function to the curve x squared plus y squared equals 13 at the point is. So they're asking us for the gradient, and I've given us the different answers here. So having this, we are going to differentiate this implicitly, because the gradient at that point will be what? Will be the value of dy by dx at that point. So we're going to find for dy by dx, and to find for dy by dx, we're going to differentiate implicitly. We're going to use implicit differentiation. So we differentiate x squared, we have 2x. We differentiate y squared, we have 2y dy by dx, because I differentiate y with respect to what? X is equals to, we differentiate 13, we have 0. Making dy by dx is so we have negative x on y, replacing the value at the point 2 negative 3. So we have our dy by dx equals to 2 on 3. And compare with the answers we have. Question 23. Question 23 says that to find the value of sine 50 plus sine 40. Yeah, if you use calculator, the answer will come out in decimal. So yeah, you need to know the different formulas in trigonometry. So here we're going to use the formula of sine. If we have sine x plus sine y is the same as what 2 sine x plus y on 2 cos x minus y on 2. So we replace, we'll have that. Simplifying, we're going to have 2 sine 45 cos 5. And now we know sine 45 is with 2 on 2. So the 2 and 2 cancel, we just have our sine 50 plus sine 40 is equal to 2 cos 5. Compare with the answer. Question 24 says that the values of the constant lambda for which the plane this is and the line this are parallel. So here they're asking us for the value of lambda, which will make the plane and the line to be parallel. So if the plane and the line is parallel, what does that mean? It means that the normal of the plane dot the direction vector of the line must give us 0. So that's what I'm explaining here. For the plane to be parallel to the line, then the normal end of the plane will be perpendicular to the direction vector d of the line. So this implies that n dot d equals to, so our n here, our normal is lambda negative 3, 4, and our direction vector of the line is 2, 6, 3. So if we find the dot product, we're going to have 2 lambda minus 18 plus 12 to be equal to 0. So simplifying, we have our lambda to be 3. So yeah, question 25. Question 25 says we evaluate the integral of x on 1 plus x squared dx. So here to integrate this, we can see that if we differentiate the bottom, we have x. If we differentiate the bottom, we have 2x. So here I just have x up, so I create 2 and destroy 2. Yeah, as we see in the screen. So then anytime that you integrate the bottom and you have, anytime that you differentiate the bottom and you have the top, the answer will just be ln of the bottom. So I'm going to have half ln 1 plus x squared. Now in integration, when we integrate, if we don't have boundaries, we always put what plus a constant, so plus c. Our answer here is b. Yeah.
Please, if you found our content helpful, please like and subscribe for upcoming videos. Thank you.